In this module, we will review the formula for calculating visual angle and contrast, and we'll work through some examples together. For visual angle calculations, we can use trigonometry to calculate the visual angle if we know the size of the object and how far it is from the eye. In the formula, the size of the object is given the variable h. The distance from the object to the eyeball is given variable d. The distance from the eye to the top and the bottom of the object forms a triangle, so the angle can be calculated using the tangent function. The equation is the visual angle is 2 times arctan, or the inverse of the tangent function, multiplied by the height of the object divided by 2 times the distance. Also, we can turn the object on its side and replace height with width to calculate the visual angle across. It's the same calculation. If you're not familiar with trigonometry, this is fine. You just need to memorize the formula and be able to recognize it and plug in the variables. I'll show you how to do the calculations without needing to do the trigonometric function or calculate the arctan. We often don't use the trigonometric function to calculate visual angle. We can use an approximation. The formula for approximating the visual angle for a small check is different from approximating the visual angle for a larger check size. For small check sizes, which are defined as less than approximately 1 degree of arc wide, to find the visual angle in minutes of arc, we can use this formula. A equals 3,438 times the width of the check in millimeters, all divided by the distance from the patient to the screen in millimeters. The number 3,438 is an approximation for the inverse tangent calculation. For large check sizes, that is, checks which subtend more than 1 degree of arc, we can find the visual angle in degrees by using this formula. A, or the visual angle, equals 57.3 times the width of the check in millimeters, all divided by the distance from the patient to the screen in millimeters. So really, with regard to visual angles, there are only 2 formulas to memorize and no trigonometry to calculate. So there's a formula for small check sizes where the check is smaller than 1 degree of arc, and then we use the arctan of 3,438. And then there's a one for large check sizes where the check is larger than 1 degree of arc, and then we use the arctan as 57.3. And we simply need to memorize those numbers and the formula. Now recall that one's finger width at arm's length is approximately 1 degree of arc, or the thumb held at arm's length is approximately 2 degrees of arc. So using your finger or your thumb, you can decide if a check is a small or a large check, and then choose which formula to use. So let's do an example together. A 7 centimeter by 7 centimeter square is observed from 6 meters away. Calculate the visual angle of the square. Well, we will choose the small angle formula because the observer at 6 meters away is quite far away from the square. We begin by converting all the measurements to millimeters so that the width of 7 centimeters is converted to 70 millimeters. The distance of 6 meters is converted to 6,000 millimeters. We use the formula for small angles, which is A equals 3,438 times the width, all divided by the distance. So A equals 3,438 times 70, all divided by 6,000. The answer is 40.11, and the units are in minutes of arc. Now we will look at how to do a contrast calculation. A reminder that contrast is defined as the difference between the brightness or color of two objects, or the difference in brightness or color of an object compared to its background. To find the luminance, we measure the brightness of the brighter object using a luminance meter, and then we measure the luminance of the darker object or the background, again with the same meter. The unit of luminance is candelas per meter squared. Contrast is expressed as the percentage or ratio where we subtract the darker object from the lighter object and then divide by the sum of the luminance of both objects. And to get the percentage, we multiply that answer by 100. For example, if the dark object on the screen has a luminance of 15 candelas per meter squared, and the bright image has a luminance of 30 candelas per meter squared, we can calculate the contrast in this way. The bright object with a luminance of 30 candelas per meter squared is the maximum luminance, and the dark object with a luminance of 15 candelas per meter squared is the minimum luminance. So we take the equation which says max minus min, so 30 minus 15, and then we divide it by max plus min, 30 plus 15. So the numerator, the top number of 30 minus 15 equals 15. The bottom number of 30 plus 15 is 45. This gives us 15 over 45. And then we multiply all of this by 100 to get a percentage. And the answer is 33.3% for contrast.